All right, this is section 7.2, finding cubic roots. And so our last section, finding square roots, we said that when we find the square root of a number, we're actually finding what the side length of a square is that has that area. So if I have a square that has an area of 144, the square root of 144 is 12, which tells me what the side length of the square is. So we start off with this problem. It wants us to tell what the side length of this cube is, and this cube has a volume of 343 cubic inches. So remember, finding the volume of a cube, you're just doing length times width times height, or in this case, s times s times s, or s to the third power, for s being the side, equals 343. And so if square rooting is the opposite of squaring a number, then cube rooting or cubic rooting is the opposite of cubing a number. And so your cubic root looks just like a square root, except there's a little 3 up here in the corner. And remember, we said last time a square root doesn't have that symbol. Technically, it would have a 2 here, although it's just implied that if that 2's not there, you're still square rooting. So a cube root, and we all have a cube root button. In just a moment, I'll show you where you can find this button on your scientific calculator, but it's got to be a scientific calculator. And so the cube root of 343 is 7. So the side length of this cube, or that cube root side length, is 7 inches. So a cube root of a number is a number that, when multiplied by itself and then multiplied by itself again, equals that given number. So we're multiplying it by itself and then by itself again. So there's 7 times 7 times 7 gives us 343. And so cubing and cube rooting are inverses, just like squaring and square rooting are also inverses. All right, so when we're using the cube root symbol on our calculators, I have 3 just pretty popular calculators here. You might recognize one of them that you might have. And so the first one is a Casio, and there's a couple different ways you can do it on a Casio. The easiest way is using this button right here that I'm circling. You can see it's the cube button. So if I just type 4 and hit cubed, it'll give me that answer. But right above that in gold, you can't really see it because it's blurry unless you actually have this calculator. You can see the option for the cube root up there. So you're going to have to hit that button using the shift button, and then use the type whatever number, or hit that button, hit shift and then hit that button, then type whatever number you want to do the cube root of. I have a calculator like the second one here, and so for this second one, you can see right here, we don't actually have a shortcut that's already got the 3, but we do have this button right here, which has, it looks like this, has an X right there. And so I need that X to be a 3. So what you would do is that you would hit 3 on the calculator, and then you would hit second function, and then hit this button here. And so again, I'll repeat that. That was hitting 3 on the calculator, and then hitting the second function button, and then hitting that little exponent arrow right there. And that will put the 3 right where that X needs to be. So it's a cube root. And then you just type in whatever number. Some of you might have calculators that look more like this one on the right. And on this one, it's one where you can't actually see what you're typing into your screen like you can on the other two. And so for this one, what you're actually going to do is you're going to hit 3 first, and then your little button is here. You can see we're up here in the corner. It has X and it has the Y. So you're going to hit 3 first to put the 3 right there. And then the second button, the shift button, I guess, or the second function button, and then you're going to hit the X to the Y. So it gives you this little one right here that we're looking at, and then you just type in whatever number you want to do the cube root of. So try that. For example, try doing the cube root of 343, which we just said in the previous problem is 7, and see if you get 7. If not, try putting it in a different order until you figure out how to use your calculator to solve these problems. So a perfect cube, just like a square or a perfect square, perfect cube is a number that can be written as the cube of an integer. So when we use the square root and we square root certain numbers, we get perfect answers. So 64 is a perfect square, and also 343 then wouldn't be a perfect square, but it would be a perfect cube because that gives us 7 when we cube root it. So as mentioned in the previous section, squaring a number always results in a positive answer. And that's because if you have a positive number, a positive times a positive is positive. And if you have a negative number that you're squaring, a negative times a negative is also positive. So it always results in a positive answer. So I can't take the square root of negative 64 here because, well, there isn't, the only way I can get negative 64 is by multiplying 8 with negative 8, but that's not squaring a number, so that's out. We would say it's not real. However, let's check out what happens when we try cubing a negative number. So if I cube 2, that means 2 times 2 times 2, which is 8. And if I cube negative 2, that means negative 2 times negative 2 times negative 2, which is negative 8. So we can get negative numbers when we cube a number. We cannot get negative numbers when we square a number. But we can get negative numbers when we cube a number, which means if you're asked, like you can see here in the next examples, if you're asked to find the cube root of a negative number, you can do that. You just can't do it for square roots. So we already know example A here is going to be 2, because 2 times 2 times 2 is how we got 8 in the previous problem. And then example B, it's the cube root of negative 125. And you can enter that into your calculator, or you might already know that 5 times 5 times 5 is 125. So the negative answer would be negative 5 times negative 5 times negative 5 gives you negative 125. Example C, when we square root fractions, we square root the top and bottom, and when we cube root fractions, we cube root the top and bottom. So it's just like before, the cube root of 1 over the cube root of 64. So that's going to be 1/4. And then for example D, same thing, except this time we have a negative, so it will be a negative, because again, you can take the cube root of a negative number. It will just be negative. And the cube root of 27 is 3. And the cube root of 1,000 is 10, because 10 times 10 times 10 gives you 1,000, so negative 3/10. Now, just like in our last section, we might encounter a problem like this one in example E, where the number that we're cube rooting, 192, and then 3, those are not perfect cubes. So you'll get irrational numbers when you try to cube root a number that's not a perfect cube. 1,000 and 27 and 64 and 1 and 125 and 8, those are all perfect cubes, which is why we got such nice answers. But 192 and 3 are not. So if you encounter a problem like this, which you will, make sure you see if you can reduce that fraction first. And I know that 3 will actually go into 192 because, remember, we can add the digits up. And if 1 plus 9 is 10 and 10 plus 2 is 12, 3 will go into 12, so 3 will go into 192. It's just a matter of figuring out how many times it will. So 192 divided by 3 is 64. So this all just reduces to the cube root of 64, which is 4. 4 times 4 times 4 is 64. One thing I definitely need to go over with you is what happens when you apply parentheses or use parentheses for these problems. So do parentheses matter? And so I want you to solve these 4 problems using your calculator. Try entering these 4 problems in exactly as you see them into your calculator and write down what your results are. I'll give you a second to do that. Okay, so if I do negative 2 squared, my calculator is going to tell me that answer is negative 4, which might surprise you because we just said that when you square a number, your answer can never be negative. However, your calculator uses order of operations, and therefore it's going to say that you're only applying the square to the number 2, and the negative in front of it is treating it like you're multiplying that answer by negative 1. So your calculator sees this as squaring 2 and then putting a negative in front of it. That's what your calculator sees that at, because that's actually how order of operations works. The exponent only squares the number directly below it. And so in this case, the exponent only sees the 2. Actually, when I talk about this in my other classes, I say that the exponents are nearsighted. They only see the number in front. And so this example down here, negative 2 to the third power, is going to be the negative version of 2 times 2 times 2, which is 8. Now, to make sure you get the proper answer, when I want to square negative 2, I have to use parentheses even in my calculator. The parentheses act as a sort of magnifying glass, if you will, for the exponent to see the entire number. So when you put parentheses, the exponent knows, okay, I'm squaring this entire number. And negative 2 times negative 2 should give you 4. So it matters. But something interesting happens if we cube negative 2. This one is going to be negative 2 times negative 2 times negative 2, which is actually still negative 8. We actually get the same answer. Here we got the answer because it made it negative. And then over on the right side, we get the answer because it repeated the negative. So we actually get negative 8, but for 2 different reasons, but we still get negative 8. And so what you'll find out is that when you are working with even powers, like 2, it will always be positive, or the answer will always be positive. And when you're working with odd powers, which you guys use this more as you progress through, but when you're working with odd powers, the answer can be positive or negative. It just depends on what your base is. So the exponent only applies itself to the negative if it is in parentheses, and that's going to be very important to note for the homework. So again, just to review, if I want to square the negative 7, then I need to put negative 7 in parentheses in my calculator so that it knows you're doing negative 7. Because if I wanted to square negative 7 and I type it in like this into my calculator, it's going to tell me the answer is negative 49, which is not true. Your calculator is only going to square the 7 instead of the negative 7. So if it says, what is negative 7 squared? You'll even see the problem will probably have parentheses around it. Make sure you enter it into your calculator that way. Or, I mean, if you just know, obviously common sense would tell us negative 7 times negative 7 is 49. All right, so let's practice that. Let's look at 4 examples where we just are determining whether the answer will be positive or negative. And so in this first one, negative 1 squared means negative 1 times negative 1. There are parentheses here, right? So the parentheses act as a magnifying glass. The exponent does see the negative 1. So it does negative 1 times negative 1, which would be positive 1. In example B, the exponent does see the negative because of the parentheses. However, because it's an odd exponent, that means there's going to be an odd number of negatives, which means your answer would be negative. So we have a negative. Last one was positive. In this one, we have negative 4 squared, but it's not using parentheses. So the exponent is only going to apply itself to the 4, which would be 16, but then you drop down the negative to get negative 16. And so the answer will be negative. Again, all because of the parentheses, or the lack thereof. And then for example D, the exponent does not see the negative, so it drops it down. And then 4 times 4 times 4 is 64. So, oops, I guess I should write this down here. Negative 64. So this one would be negative. So I guess a pattern you might recognize is if you're using an exponent, if you're raising a number to any power and the base of your number is negative, but there's not parentheses, then the answer will always be negative. The parentheses will determine whether or not it's going to be positive or negative, and it's all going to depend on what the power is. As you can see in example A and B, the base is negative 1, but raising it to the second power, since that's even, gives me a positive answer, but raising it to the third power, since 3 is odd, gives me a negative answer. All right, so let's evaluate some expressions. As I mentioned in our previous section, when you are square rooting or cube rooting a number, that's actually going to take place in the exponents part of order of operations. Please excuse my dear Aunt Sally, PEMDAS. So exponents, and again, that was because when you square root a number like 64, you can say that you're raising 64 to the 1/2 power. So there's actually an exponent that can be involved there. If I'm cube rooting 64, I'm actually raising 64 to the 1/3 power. So again, I'm going to do my cube roots where I would normally do the exponents in my order of operations rules. So that means in example A, I'm going to cube root negative 216 before I do anything else to this problem. And the cube root of negative 216 is negative 6. And I copy down everything else as I funnel my work down. Multiplication would happen next. Negative 12 is what 2 times negative 6 is. And then negative 12 minus 3 is negative 15. In example B, I have to cube root first. However, I'm also cubing. And so like we said yesterday, or in our last section, that cubing and cube rooting are inverses, so they'll cancel each other out, just giving me negative 15. If I cube root and then turn around and cube a number, those will cancel each other out. And so negative 15 minus 21, I've got same signs. Well, I will once I rewrite it. Same sign, so I'm going to keep the sign and add. I'll get negative 36. A couple more examples. In example C, we have to cube root the 8 before we do. And a very common mistake is to want to jump into this 18 minus 4. I cannot do 18 minus 4. Subtraction is actually the last step in order of operations. I cannot do 18 minus 4. I have to cube root 8 first, which is 2. Then I have to times 2 by 4, which is 8. And then I have to subtract 18 minus 8, which is 10. And you'll get a very different answer if you do 18 minus 4 first. We cannot do that. Okay, the next one. I'm supposed to cube root this entire thing. So I'm going to pretend like this is in parentheses. I have to know what's under this cube root symbol. So I'm going to have to do negative 555 plus 43 first. Okay, so when I subtract, because they have different signs, so I'm subtracting, I get negative 512, and then I'm going to do the cube root of that, and then I'm going to multiply that by 5, negative 5. And so the cube root of negative 512, it's going to be negative. Remember, I can cube root negative numbers. I just can't square root them. And so that's going to be negative 8. And then I'm going to times that by negative 5, and we'll get positive 40. So make sure you show your work on these problems for your homework. These next two problems, just like the one we started off with this section, we're just cube rooting because we have the volume. So if I'm cube rooting 0.001, if I try typing that into my calculator, make sure you cube root it, not square root it, you'll get the answer 0.1. So S is going to equal 0.1 centimeters cubed. That's because 1 times 1 times 1 is 1, and 0.1 times 0.1 times 0.1, remember I've got 3 decimal places, will give me 0.001, because I have to have 3 decimal places in my answer. And the next one, I'm going to cube root my fraction of 1/8, which is going to give me 1/2, because remember I'm just cube rooting the top number, which is 1, and cube rooting the bottom number, which is 2. So 1/2 of a yard. For the next example, I've got a baseball in a case here. It says find the surface area of the baseball display case if the volume is 125. And so in order to find the surface area, I need to know what the side of the case is. And so because the volume is 125, and because I know to find the volume, you would do S to the 3rd power, right? You do side times side times side. I'm going to cube root 125. And that's going to tell me that the side of each of these, each side of the cube is 5 inches. So 5, 5, and 5. Now to find the surface area of the cube, so again, the volume, you do length times width times height, but for the surface area of the cube, you have to do the area of all 6 sides. And because it's a cube, all 6 sides are the same. So the area of one side would be 5 times 5, or 5 squared. And then there's 6 sides like that. So 5 squared is 25. And if the area of each side of that display case is 25, there are 6 sides, because I'm doing surface area, not volume anymore. 25 times 6 is 150, and because it's area, we would label our answer in square inches. All right, let's wrap up this section. It says complete each statement using positive or negative. Let's see how well we can remember these. It says a positive number times a positive number is a blank number. And so if I'm squaring a positive number, positive times a positive, that's going to be positive. A negative number times a negative number. What's that going to be? Well, a negative times a negative is also going to be a positive number, which is why anytime we square a number, it has to be positive. Example C, a positive number multiplied by itself twice. Well, if you're cubing a positive number, a positive times a positive times a positive is still going to be positive. And then for the last one, a negative number multiplied by itself twice. A negative times a negative times a negative is going to be negative. These two negatives will pair up, but there'll be one left over. So I can get a negative answer when I cube a number, which means I'm allowed to take the cube root of a negative number. I'm not allowed to take the square root of a negative number.